Alright, so we are going to look at the carboxylic acid. Now, carboxylic acid are an organic acid and they contain the functional group ROCOOH. Alright, examples are, we have an example here that was given to us, formic acid, the simplest carboxylic acid. Formic acid from ants. Formic acid. Alright, now when compounds contain only one of this COOH group, if it is only one of the COOH group, they are called monocarboxylic acid. However, when the compounds contain two COOH group, they are called dicarboxylic acids. Alright, now if a carboxylic acid is like this, the common name is formic acid. However, if it has two carbons, the common name is acetic acid. If it has three carbons, the common name is propionic acid. If it has four carbons, the common name is butyric acid. And if it has 5 carbons, which sometimes they might decide to write like this. Do you know what this means? Means you have CH2 into 2 places. So this is already 2 plus this 2 here, making it 4 plus this one 5. It is called valeric acid. And then the chain continues like that. Now, in carboxylic acid, there is a particular way of naming them, especially when you want to use the common naming system. Now, after this first carbon carrying the COOH, the next carbon is called the alpha carbon. The next to that carbon is called the beta carbon. The next to that carbon is called the gamma carbon. And the next is more like the delta carbon, and so on and so forth. So if you have a substituent on this gamma position, you're not going to say gamma, let's say the substituent is chloro. So you say gamma chloro what? 1, 2, 3, 4, 5 valeric acid. If it's, let's say, at the beta position, and then let's say methyl group is here, you're not going to say beta methyl valeric acid. If it's hydroxy group that is here, become beta hydroxy valeric acid. Is that okay? Now let's look at some of the method for preparation. Now, I have actually discussed this in the reactions of aldehydes, so I'm not going to waste time. Aldehydes and ketone, so I'm not going to waste time here. The first reaction here is oxidation of aldehyde. We said when aldehydes are oxidized, first of all, it comes from alcohol. But we said whenever aldehydes are oxidized using any of these oxidizing agents here, let's say K2CR2O7, we say this one must take place in acidic medium. The product will be a carboxylic acid. Alright, so this is ethanol. The product for this will be ethanoic acid. Do you understand it? Exactly. Now from alcohol, same thing from aldehyde. We said from alcohol, from what I taught you earlier, you can get to what? Using any of these oxidizing agents, you can get to aldehyde. Can you remember? and then from aldehyde oxidize it again, you will get to what? Carboxylic acid, especially only primary alcohol. So this alcohol that will react must be a primary alcohol. Then this is what? Aldehyde. Further oxidation will give us carboxylic acid. Very easy, right? Exactly. Now, from hydrolysis of cyanide. Now, when cyanide are hydrolyzed or is hydrolyzed, gives us the carboxylic acid, and it finds so many synthetic utility, especially when you are not talking about the synthesis of ibuprofen. I think the last step for the synthesis of ibuprofen, which is your common non-steroidal anti-inflammatory drug, NSAID, that you use for as an analgesic to keep pain. Maybe you're having a headache or some kind of pain somewhere, you take ibuprofen. Those of you who are having menstrual cramps, you take ibuprofen, right? The last step in the synthesis of ibuprofen requires the hydrolysis of the cyano group to what? Carboxylic acid. All right? But these applications is only peculiar to pharmacy students. But you should just know that most of these things you are learning under organic chemistry has application in the real world scenario. You are not just cramming and memorizing things. All right? Good. So we have the hydrolysis of the cyanide. So how do we form cyanide? We start with alkyl halide. For instance, if you have methyl bromide, which is, I would say this is methyl bromide. All right. Now, with reacting it with sodium cyanide in sodium bromide, what do you think the product will be? This cyano group here will replace this bromine. So you are going to have CH3. This is the cyanide. Whenever you see anything CN, like, you just know that it's triple bond that is present there. All right, like this one is triple bond that is there. So this is the cyanide that will form. This cyanide now will undergo acid hydrolysis. Usually acid hydrolysis. This process is called the hydrolysis stage. That is where we talked about hydrolysis. But the hydrolysis is sponsored by what? Acid. That is why you have the H plus here and then water, hydro. That will give us the corresponding carboxylic acid, which should be CH3 COOH plus ammonia. All right, it's going to form ammonia at the end of the day. Ammonia from here, from the cyanide. Is that okay? That is that. So that is one of the methods for preparing carboxylic acid. Now let's see another method from carbonation of Grignard reagent. You know what Grignard reagents are? ROMGX by Victor Grignard plus CO2 carbonation. That means you're actually adding carbon to Grignard reagent. Now, you know CO2, if I really want to write CO2, I'll write it as something like this. Okay, first of all, let's write the reaction. This will give us RO COO, which is like CO2, and then MgX. Hydrolysis of this, which is also acid hydrolysis. You know, for Grignard reagent, we'll be discussing since the last step is usually acid hydrolysis, where this MgS will be replaced with what? Hydrogen, right? So this is going to give us ROCOOH. Is that understood? How does this actually take place? You know, this CO2 can be written as this. True or false? True. Exactly. Now, if you write that as that, Grignard reagent is ROMGS. I told you that this arrow will break to become negatively charged. MgS will become positively charged. This one will come here, attack here. What did you say will happen to this? This one will pack. It could be this one that will pack. It could be this one. All right. And then I want that one to pack. We are going to have arrow C double bond O. Okay. The arrow can be under here. Arrow C double bond O, which is this, and here will be what? O negative. What do you think will happen to this O negative? Mgx positive will attack, and then after the hydrolysis with water, this Mgs will be replaced with hydrogen, and then you are going to have arrow C double bond O. This arrow is still saying arrow C double bond O, and then here we change to what? OH, which is carboxylic acid. Is that okay? So that is that. Now the next one is from the hydrolysis of ester. Hydrolysis of ester. But this mechanism is quite different from the other hydrolysis we've looked at before now. Now, what is an ester? This is an example of an ester. And then you have O, C2H5 plus sodium hydroxide. Now, when you heat this, what do you think will happen? Listen, it's very easy. The sodium will come and attach here. C2H5 will come and be with OH. Alright? So that at the end of the day, you are going to have CH3, C double bond O. Here will be what? O, Na positive. Here will always be negative. Plus, I told you that this C2H5 will come and attach with what? OA. So you have C2H5OH. Now listen. This sodium here can react with what? Hydrogen chloride. Can react with what? HCl. So this will give us CH3, C double bond O, O negative, Na positive, plus HCl. Now, at the end of the day, what do you think will happen? Another substitution will take place here, where this hydrogen will come here, and then sodium will bond with chlorine. When sodium bond with chlorine, going to form what? Sodium chloride. So here will give us C double bond O, and here will be what? OH plus what? Sodium chloride. What do we have here? We have the carboxylic acid, which is in this case is what? Acetic acid. Is that okay? Exactly. So that is one of the methods of actually forming this. Another is preparation is for malonic acid synthesis. Now this involves the reaction of, first of all, what is malonic acid? Malonic acid is something like this. I'm going to show you something now. COOH. Now when this acid is complexed with an ester, it's now going to give us, complex with alcohol, is going to give us the ester. So this one is the malonic ester. Are you getting it now? But now this malonic ester, we can have the sodium salt of the malonic ester. So what you have here is the sodium salt of the malonic ester. Now when the sodium salt of the malonic ester reacts with alkyl halide, what do you think will be formed? Now at the end of the day, sodium halide will be given off. That means this sodium will combine with this X, and both of them will go. Then this arrow will come to this position, so that at the end of the day you now have arrow CH. Here will be COO, C2H5, COO, C2H5. Are you getting it now? This one is called sodium ethyl malolate. All right, sodium ethyl malonate. So this is going to form something like this. Now the next step is hydrolysis. Now whenever you hydrolyze ester, they are going to give us the corresponding carboxylic acid. So it means this group you see here like this, what is the corresponding carboxylic acid I drew initially? I said is COOH. It was not until ethanol, which is alcohol, is complexed with the ester, because you know that a reaction between carboxylic acid and alcohol will give an ester. So this is the carboxylic acid. When esters are hydrolyzed, they give